What is energy conservation really protecting? Is it just about keeping a mysterious number constant, or is there something deeper? To understand this more clearly, let's think about it from a different perspective. The universe doesn't allow energy to disappear, nor does it allow it to spontaneously appear from nowhere. Instead, the way energy functions is all about maintaining a balance. The universe doesn't let you erase the cost of altering the state of things, it just redistributes that discomfort. The key to understanding this in the framework of the energy filament theory is that energy represents the amount of disturbance in the fabric of space, what we call the energy sea. When you push a cart, break a car, light up a room, or set off fireworks, you are moving the same discomfort from one place to another. It's the same energy, just redistributed. Imagine playing a card game with friends. There's a fixed number of chips on the table. When you take chips out of your pocket and place them on the table, you're making yourself lighter, but the table itself feels heavier. The total number of chips hasn't changed. If you win a hand, you're simply taking on the discomfort that someone else has let go. No extra chips have appeared and none have disappeared. This is exactly how energy conservation works. It's not that energy disappears or is created. It's that energy moves, changes forms, and gets redistributed. Whether you're pushing a cart, applying brakes, lighting a light bulb, or even watching a fireworks display, you're simply moving energy from one place to another. For example, when you push a cart, the energy used to move it isn't lost or used up. What's happening is that the discomfort caused by your muscles is being transferred to the cart's wheels and the ground beneath them, taking the form of friction and heat. When a car brakes, the kinetic energy, the car's speed, doesn't vanish, but gets transferred to the brake pads and air as heat and vibration. The same principle applies when you flip a switch to light a bulb. The discomfort, or energy, moves through the wires and into the filament, causing it to heat up and produce light. In each case, the energy isn't lost, it simply moves into a different form or place. But what about when we say that energy is disappearing? It doesn't actually vanish. What happens is that energy gets spread out into smaller, less noticeable forms. You might not see it, but the energy is still there, just in a form that's less easy to track. It's like when you stop focusing on one particular source of energy, that energy is still there, only now it has dispersed into other parts of the system. For example, when you push a cart, you're transferring energy into the friction between the wheels and the ground. And that energy isn't lost, but transferred into heat. In fact, the principle of energy conservation is about ensuring that energy is never truly lost. Instead, it's always redistributed. Every time you do work like pushing a cart, applying brakes, lighting a light bulb, or even setting off fireworks, you're redistributing energy. The energy moves from one location to another. It's like a constantly flowing river of energy. The energy doesn't disappear, it just keeps moving, changing, and flowing through the system. Let's zoom out and see how this works in the bigger picture of the universe. When you stand on Earth, you're standing on a complex web of forces and energy interactions. The Earth, your body, and the surrounding environment are all parts of an energy network, a web that redistributes energy constantly. Gravity pulls objects down, but it's not some mysterious hand grabbing them. Gravity is simply the result of energy moving along this web, and everything in the universe moves according to this principle. If you jump, for example, gravity causes you to fall, and when you land, the energy is redistributed into the ground and the surrounding environment. But energy isn't lost, it just moves into different forms, like heat and motion. So, energy conservation isn't about some mysterious substance staying forever intact. It's about the overall balance of energy in the universe. No matter how much energy we move around, the total energy doesn't change, it just shifts. And this principle applies to everything, from the tiniest particles to the largest galaxies. Energy moves around the system, and the total energy remains constant. In the next episode, we will explore how energy conservation is connected to the fundamental forces of nature. What does it mean for gravity, electromagnetism, and other forces that govern our universe? Stay tuned as we dive deeper into how energy shapes everything around us. Tap follow, share it on New Physics, Clear Universe.